Welcome back to Prescriptive Analytics, and we're going to take an example of a production planning process and how we can optimize it. My name is Hari Rajagopalan, and I'll be continuing this lecture for you. So let's take an example of Upton Corporation that manufactures heavy-duty air compressors for home and light industrial market. They want to plan their production plan for the next 6 months, and because of seasonal fluctuations in utility raw material costs, the per unit cost of producing compressors varies from month to month, as does the demand for air compressors. So production capacity varies from month to month due to differences in working days, vacations, scheduled maintenance, and training. And given the size of its warehouse, a maximum of 6,000 units can be held in the inventory at the end of any month. And the owner likes to keep at least 1,500 units as safety stock. So to maintain a stable workforce, the company wants to produce no less than 1/2 its maximum production capacity each month. And the Upton controller estimates the cost of carrying a unit in any given month is about 1.5% the unit production cost of the same month. So, the number of units in a month is calculated by averaging beginning and ending inventory. Now, this sentence is very important because you might have a change where they say it's only the ending inventory, in which case you have to do it differently. Okay, you have to calculate it differently, and we'll talk about that. So there are currently 2,750 units in inventory. That's your beginning inventory, and here is the information given for you the 6 months. Here's the production cost. Here's the demand. Here is the maximum production. And this is the minimum production, which needs to be done, which is essentially half of the maximum production, the capacity. So we're going to create a math model and solve it using linear programming. So let's think about this, and let's kind of distill the information we have. Beginning inventory is 2,750. Safety stock has to be 1,500 units. Unit carrying cost is 1.5% of unit production cost. That's your inventory cost, right? Maximum warehouse capacity is 6,000. And then here we have the other set of information we have. So let's kind of think about this problem and start looking at what we need to look at. So obviously we need to figure out how many units have to be produced, right? So production definitely, when you're looking at this problem, you definitely have to look at production each month, right? And this production then leads to inventory, right? So while you don't really decide on inventory is calculated based on how much you produce, and then you got to look at your demand, and then the difference between the two, you got to look at beginning inventory, right? And then there is the ending inventory. So beginning inventory plus production minus demand will be equal to your ending inventory. So inventory is another decision variable which needs to be taken into account. So let's look at all the different decisions and decision variable and how to model this problem. So we'll start with the production planning. So let's say PI is the number of units produced in a month. So we have P1, P2, P3, P4, P5, P6, 6 variables here. And here we go. Then we have beginning inventory, B1 to B6, right? And then we have ending inventory, or E1 to E6. Now, you don't really need this ending inventory, but I'm just putting it in so that it makes it easier for you to understand. The model is easier to understand. But when we look at the Excel file, I'll show you a model without using this E and just using B. So we're going to minimize production and inventory costs, right? So your production costs are per unit production costs are given. Your inventory costs are beginning inventory plus ending inventory divided by 2. and then you're multiplying it times your 3.6. And how did we get this 3.6? Let's go back. Remember, it's 1.5% of unit production cost. So 1.5% of 240 is, this is 240, 1% is 2.4, half percent is 1.2, so 2.4 plus 1.2 is 3.6, and that's basically how you get your 3.6. Similarly, 3.75, this is one point, the same formula, right? And so you're going to calculate your inventory costs here. Now, this has to be expanded because you got 1.8 B1, and then you'll have 1.8 E1, and so on. Okay, you've got to expand it. And it's subject to, first is you have a certain level of production levels. There's maximum production and minimum production, right? So we have half of it, you have to produce this much, half of the maximum production. You also have ending inventory. Here's the safety stock, and here's the maximum level you can have ending inventory. And then finally, for each month, you have beginning inventory starting off at 2750, and the ending inventory is beginning inventory plus production minus demand. So you need to move all of this where all the variables come to left-hand side and all the numbers come to the right-hand side. So my advice would be to move 1000 and then move E. So B1 plus P1 minus E1 is equal to 1000. B2 plus P2 minus E2 is equal to 4500, and so on. So, and also the last part, because your ending inventory for this month is equal to the beginning inventory for the next month. So you got to equate that. E1 minus B2 is equal to 0, E2 minus B3 is equal to 0, and so on. Okay, and then finally the non-negativity constraints, where you're saying P, E, and B are all greater than or equal to 0. PI, BI, not XI. PI, BI are all greater than. And there, as you see, I fixed it. It was XI, but I changed it to PI, EI, and BI. It is very important not to use letters you have not defined already. Okay. All right, so let's go to Excel and see how we're setting it up. And I'm going to show you multiple setups and multiple models in Excel here. Okay, so let's look at this and let's look at how it's set up. We take this, we expand these values. So for example, 3.6 divided by 2, if you go here, that's 3.6 divided by 2. Similarly for B2, we have 3.75 divided by 2, so you can go ahead and put that in. And then here 1.99 and so on, right? So go ahead and put these values in. So we could go ahead and change this to 1.875, 1.875. And my advice to all of you is to go ahead and put these fractions as it is in Excel, so Excel can calculate the actual amount without rounding off, and that's creating problems, right? If you go ahead and put 1.88 here, that automatically will change the answer. And so you don't want those rounding off errors. So go ahead and put those actual values and don't worry about the decimal points. Put the fractions in. Here, of course, we have for production levels, we've gone ahead and put min and max, and we've said these values would be greater than this and less than this. That's what we have here. And then we have for your ending inventory, again, you have your minimum and maximum values. That's what we have here. And then here, we've got this B1 is equal to 2750. Some of you might want to put 2750 here as an equal to, and then just say B1 is, you can make it a bounds constraint. That's fine. And the rest of it appears here. As you can see, you have B1 plus P1 minus E1, and that's what we have here, right? And this is the constraints which you have here. And the last bit is the linkage between B2 and E1, right? You've got to link them. which I'm just taking the zeros out. So you're essentially saying these are linked together, and that needs to be also put here. They aren't here, so we need to have this whole thing where we say um, E1 is equal to B2, E2 is equal to B3, and so on. And that's here, right? And so once we run it, you get your answer. Now, I want to show you a second formulation, an alternate formulation where you don't have to use ending inventory. Given that your E1 is nothing but B2, you can go ahead and replace B2 here instead of using E1, E2, E3. You can put B2, B3, B4, B5, B6, and B7 because the beginning inventory of the next month is equal to the ending inventory. And so you'll notice then here that makes this a little bit more complicated because you have two B2s here. You have 1.8 and then 1.875 or something like that, and then you got to add the two. So you have a little bit more calculations to do. However, that reduces your structure of your the problem and how you set up. It reduces your setup here to a much smaller extent. Okay, so you can do it this way, or I prefer to add the E because it makes more sense to me. And then make sure that you do have E2 is equal to B1, E3 is equal to B2, E4 is equal to E1 will be equal to B2, E2 is equal to B3, E3 is equal to B4, and then E4 is equal to B5, and then E5 is equal to B6, right? You've got to put those in, and then, of course, E6, we don't have B7 here, so you don't have to worry about that, okay? So it's important that you have them here so that they are set up properly. So this one is ending inventory equal to beginning inventory of next month. Okay. Or you can choose not to do it. The book has some changes where what they do is you notice that B2 is equal to this value, and what the book does is actually puts these formulas here, which makes it a lot more complicated than it should be. So I prefer not to use the book's formulation, but here's an example of how the book formulates it. If you want to use that, that's fine too. So all three formulations are correct. I prefer to choose this, use an extra variable, which makes it self-explanatory, have a beginning inventory and an ending inventory. It is also some of you might be able to do this entire thing with just using the production values, because obviously production is linked to the beginning inventory and the ending inventory, but I prefer not to do it. And so this is your Excel file.